All right, hey guys, sorry I forgot to push record, so this is me going back and doing it now. So I just wanted to do like a little bit of review about how squares and square roots even work, right? Just to get the basics here. All right, so the way this works, you guys should remember this from my classroom, right? They have the same thing up on the board there. But if we go back and say, okay, what is, well, 4 squared, what does that give you? What does that even mean, right? 4 squared. So if you remember right, 4 squared really means 4 times 4, right? Not 4 times 2. It's 4 times 2, or 4 times 4. Because the squared part is telling you how many times it's multiplying by itself. So if this was 4 to the power of 3, well, that would be 4 times 4 times 4. That's what that's saying, okay? But we're going to focus, especially in grade 9, on like the 4 squared part of it, okay? So now, so that'd be 4 times 4, which would be 16, right? Or 4 squared is equal to 16. Now, the square roots half of this is just going the other way. So that's just saying, well, what if I had 16 and I wanted to figure out what the opposite was, like going the other way around? Well, I could say the square root of 16 is equal to 4, right? So they're just back and forth. So 4 squared is 16, and the square root of 16 is 4. So you just go back and forth all you like. They're inverse operations of each other. So it's kind of the same thing as if you multiply by 2 and then divided by 2, you get back to the same number, right? So that's what a square root is, right? So yeah, I think that kind of says it. Hopefully you guys kind of remember a bit of that. But if we do ones with fractions, they're actually not that bad. So if we write this out as 144 over 25, okay, well, all this is going to be is it's the square root of the top divided by the square root of the bottom. So the square root of 144, it's even on my number line. Oh, it used to be. Oh yeah, there it is. 144, the square root of that is 12, right? Because 12 times 12 is 144. So the top here is just 12. And then over, and the square root of 25 is 5. And that's it, right? There's your answer. That's the square root of this one. Which, the fact that I ended up getting a number out of this, right? Just like a nice number, that means that this was a perfect square, right? What the flip side of that is something that's not a perfect square or a non-perfect square would even be something like as simple as the square root of 3, right? So if you put in your calculator the square root of 3, so square root of 3, you end up getting 1.73205, and then it goes on and on and on forever, right? Well, that's an irrational number. That's by definition an irrational number. It just never repeats there, right? So it didn't give me a nice number that I can, like, I can't take this and go, okay, well, this squared gives me this, right? It doesn't work out that way because I can never get that whole number into there to square it, right? So it's not a perfect square. So you would say 3 is not a perfect square, but even this fraction, even this one we put in here, that was a perfect square because we got a nice ratio out of it, right? I can take this squared and get this back out of it again. Okay, so hopefully that made sense. Now let's just really quickly, I'm going to do just one of these other examples here, like this one. So let's go the square root of 1.69, and if you put that into your calculator, you'd get square root of 1.69. You get 1.3. Okay, which kind of makes sense because 13 squared is 169. So we just really had to move the decimal to the right spot there too. But this is a perfect square because I got a nice number out of it, 1.3, right? I could square that and I'd get 1.69 back again. Okay. The other way of doing this though is if it wanted the answer, let's say, as like a fraction. Well, this is how we do it. I'm going to rewrite 1.69 as, well, it's going to be 169 over, and all I did there was I moved the decimal 2 times to the end of this number, right? So 2 times the end of this. So that's what it'll be over. It'll be over 1 with 2 zeros because I moved the decimal 2 times. Another way of thinking about that is that, well, the 9 here is in the hundredths spot. That's why it's now over 100. That's what that decimal means. It's over 100, right? Okay, so now that I have it written out like that, now it's just like what we did in this example, where I'm just going to take the square root of the top and divide by the square root of the bottom. So the square root of 169 is 13 over, and then the square root of 100 is 10. So it's 13 over 10. And that really is the same thing as 1.3, right? All right, so that's how you do those ones. And I think this is where I started recording in the last one, so I'll end this video here.